Okay, let's keep going on these examples. When we look at this problem, remember that we have a fraction we have to simplify, and then we have three separate bases we need to deal with. So let's deal with this 15 over 3 first. 15 over 3 would simplify to be 5 over 1, a to the 7th over a squared. We would keep our base of a and subtract our exponents. So a to the 7 minus 2, that's top heavy, so we're going to end up with canceling out these guys, and we'll end up with a to the 5th in the numerator. Remember that even though we have that rule, keep the base, subtract the exponents, I really prefer thinking about having a. And I can think about the fact that I would cross out or make two different pairs become ones. And that would leave 5 A's that wouldn't have a pair. The reason I really like that is because here when we get to this B value, this base of B, we would be able to cross out 3 pairs, leaving the top empty or the numerator empty. When we crossed out 3 from the bottom, we would be left with B to the 5th. C to the 4th over C to the 4th. Well, that's just going to become a 1. So we now have 5A to the 5th over 1B to the 5th. Would you please pause the video and give number 8 a try? I really want to see if you understand this or if you're struggling. All right, well, maybe you started looking ahead after you worked on number 8. And if you had trouble with number 8, let's talk about it in class tomorrow. Let's move to number 9. Actually, yeah, let's move to number 9. Y to the 3rd over y to the 3rd. Well, hopefully you don't have to think about that one too much. Here's where I said that tricky stuff. Look at this set of parentheses being raised to the 0 power. That makes this whole fraction with all of its exponents one individual base. And any base being raised to the 0 power is equal to 1. Just be careful. You have to watch the parentheses and which base is actually being raised to the 0 power. There is definitely a trick question. Let's look at 11. A to the negative 3rd power. Sometimes when they give me a negative exponent, sometimes I find it easier to put that fraction bar in so that I can see what needs to happen. So that we know it's really over 1, but that 1's kind of invisible. So I'm going to cross it out so I know that that's an invisible 1. And in order for us to have a positive exponent, this a to the negative 3 needs to change sides of the fraction bar. So it's going to go to the denominator so that the exponent can become positive. Now, this is all that needed to move. That invisible 1 is still there, right? There's still a 1 a to the 3rd because that 1 didn't have to move. But we're not allowed to leave this numerator empty. So the invisible 1 that's in the numerator, it just needs to become visible. So that the common way to write this answer is to just simply put 1 over a to the 3rd. Be careful. It's a common mistake to think that I flipped my fraction over, when in fact I didn't. Because this next problem, right, it's already got the fraction bar in it, so we'll put that fraction bar in. This base of 1 has a positive exponent, so it's going to stay in the numerator. And this base of a has a negative exponent, so it needs to move to the numerator in order to become positive. There was an invisible 1 down here. There's still an invisible 1 down here. But 1 over 1, well, all those invisible 1s get to go back to being invisible. We don't ever have to actually write this. But I wanted you to see what happens so that you don't make any common mistakes. So that we end up with just a to the 3rd as our answer. All right, I'm skipping around a little bit. I want to look at number 15 for a moment. Number 15 is the spot I would like to go to next. In number 15, the first thing I would do in this problem is I would take care of those negative exponents so that a to the 3rd needs to move to the denominator and become a positive exponent. A to the 5th moves to the numerator so that it can become a positive exponent. B to the 4th, oh, that's got to go to the denominator, so it can have a positive exponent. And c squared, it has a positive exponent, so it stays in the denominator. This would be my work step. And now that my work step is done, I can apply my keep the base, subtract exponents. Notice that the a's are top heavy, so I would be able to cross out 3 of them, and that would leave me with a times a, or a squared, in the numerator. So that my answer would become a squared over b to the 4th c squared. All right, let's try number 16 because it's one of those trick problems. Notice that 5x and 6, you can't do anything with that. Those are not like terms. So when you have a problem like this, it's kind of silly and it feels really obvious, but we're just simply going to say y raised to the 5x minus 6, because we would keep the base and subtract exponents, and that whole quantity becomes an exponent. It's kind of awkward, but that's all we have to do. All right, backtrack. Number 14. In number 14, notice here we have an entire base being raised to the negative 4th power. There are 2 really good ways to do this. Most often we apply power to a power first. Most often we apply power to a power first, so that we end up with r, remember, keep your base and multiply exponents. So there are 2 bases, so there will be 2 multiplications. R to the negative 8 times the negative 8 times s to the negative 12. We're never allowed to leave a negative exponent in an answer, and since those are both negative exponents, they will both move to the denominator in order to get positive exponents. And since my numerator is now empty, that invisible 1 has to become visible again. Number 13, again, we can apply the same idea. We can do this problem 2 different ways. I think the best way to do this problem, though, is with a little bit of a shortcut and a trick. Whenever we have a fraction being raised to a negative exponent, we can actually take that fraction and flip the entire thing over, or use the reciprocal. So 2 over 1, and then our exponent can be positive. It only works with fractions raised to negative exponents. So now we're looking at 2 to the 3rd power, and 2 to the 3rd power is just 8. I know we're going to have to practice with these rules. These are probably the hardest ones in the chapter. So make sure you save this video, watch it a couple of times, take good notes, and we'll go over questions in class tomorrow. See you then.